This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day wherever you're listening from, and welcome. It's episode 465 of IAQ Radio. It's Friday, June 23rd, 2017. Our guest should be with us any moment. Today's guest is Dr. Nuno Canha from the University of Lisbon in Portugal. We're going to talk about indoor air quality, ventilation during sleep, and just a little bit on indoor air quality during sleep in general. Before we get started, we have to thank our marquee sponsors.
IAQ Radio marquee sponsors are John Don Products, where restoration and abatement contractors shop. Visit them at jondon.com. That's JONDON.com. Healthy Indoor Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions are available at IAQ.net. Legends Environmental Insurance, the experts in insurance for environmental consultants and contractors for over 20 years at legends-enviro.com. That's legends-enviro.com.
Please be sure to thank our sponsors for their support of IAQ Radio when you inquire about their products and services. And last but not least, please visit the IAQ Training Institute website for the most current dates for the training you trust at IAQtraining.com. All right. We also have continuing education credits available for those of you that need CEs for either the ACAC or IICRC or any of the other alphabet soup of acronyms out there. Just send me an email at joe.hughes, that's HUGHES, at IAQtraining.com. We'll get you out a quiz and you can get your continuing education credits. All right, let's turn it over to the Z-Man for today's IAQ Radio trivia question.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick@cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man with this week's IAQ Radio Trivia question.
Hello, everybody. The answer to our last trivia question, in what year did the NFL Hall of Fame open in Canton, Ohio, was first provided by Vic Cafaro, Richmond, Virginia. Congratulations, Vic. The IQ Radio question for today, Friday, June 23rd, 2017, has been sponsored by Ideas, the solution chemistry company, creating unique solutions to odor removal, surface cleaning, and decontamination problems. Now for today's IAQ Radio trivia question. What is the common thread running between these three incidents? The 1989 Exxon Valdez oil spill off of Alaska, the Challenger space shuttle disaster, and the Chernobyl nuclear accident. Back to you, Joe.
Thank you, Cliff. Okay, today's guest is Dr. Nuno Canha. He has a master's degree in chemistry from the University of Lisbon in Portugal, also PhD in environmental sciences from the Delft University of Technology in the Netherlands. His main research interests are instrumental neutron activation analysis, indoor air quality, source apportionment ventilation rates, atmospheric air quality, exposure to air pollutants, and biomonitoring of air pollution with lichens. He caught our attention with a paper called IAQ During Sleep Under Different Ventilation Patterns. Dr. Canha, do we have you on the line?
Yes, hello. Good afternoon to all.
Welcome. It's great to have you, and thanks for sticking around a little late today. It's probably about dinner time in Portugal.
Not yet.
Okay. All right. Well, let's talk a little bit about, what led to your interest in indoor air quality. How did you get involved in indoor air quality in your studies in college?
Well, in fact, it was not scheduled in that way, I think, because I finished my master thesis in chemistry, and I was thinking to start to do some research, but I did not have any idea of what would I do, in fact? And then I see an application to work on a research project about indoor air quality in primary schools in Lisbon. It was a research project funded by national funds that was undergoing since 2009 until 2011. And I applied to that project, and in fact I started as a project assistant in that project, where the main goal was to try to understand the indoor air quality in primary schools in Lisbon, and it was the beginning. After that, I continued my work, doing my PhD on that topic, and since then I still work on that field.
How is the indoor air quality in general in the schools in Lisbon? And can you tell us a little bit about the construction in your part of the country? Is it is it concrete, cinder block, combination, metal? How do you build these commercial buildings?
Well, most of them are concrete, basically. But one of the main characteristics of our schools, and in fact it's a characteristic that all the southern European countries have, is that our schools only have usually natural ventilation. And in fact that is the biggest problem that we have, because in winter time usually the windows are always closed, and therefore the pollutants accumulation is a lot higher than it should be, with very low ventilation rates. And I think that is one of the main things that distinguishes, at least here in Europe, from the north of Europe, for example, the type of ventilation used in the schools.
Is there air conditioning in the schools, or there is no air conditioning? They just use the ventilation to get the temperatures into an acceptable range? Well,
usually there is no air conditioning in schools. What happens is that in winter time they have electrical heaters, for example, in some classrooms. This is the typical definition of a Portuguese classroom. Of course, some years ago, I think 5 years ago, there was a national program to remodel schools, Portuguese schools, and some 200-300 schools, I think, were selected to be remodeled, and in that it was then some inclusion of air conditioning, for example, with mechanical ventilation and so on. But in those schools there was a problem afterwards, because there was not enough economical resources to maintain all the equipment working. So at the end it did not work as it was expected.
Cliff, you have a follow-up?
I do, Joe. Thank you for joining us, Doctor. The primary school that you did this study in, how old was that school? Years of age?
Yeah. It's ranged between maybe 30 years and 10 years old.
Okay, between 10 and 30.
Yeah.
And just one other follow-up. Do the children go to school year-round in Portugal, or do they have a long summer break?
They have a long summer break, a long of 2 months, I think, nowadays. Yeah.
Okay.
Only that, yeah. In fact, in my PhD, I did one interesting thing. That was, I studied the indoor air quality in schools of Lisbon, urban area, and I also did the comparison with a rural area in the center of Portugal. And in fact, the main conclusion was that the conditions, the physical conditions of the schools were in better shape in the rural area when comparing to Lisbon, for example.
The maintenance wasn't as good in the urban school as it was in the rural schools?
Yes. And we can understand that because in Portugal the schools are from the states, from the municipalities. So in the rural area, one municipality only have 10 schools, for example, and here in Lisbon, it's more than 100, I think. So the maintenance in Lisbon, in the urban area, is a little bit worse, I can say that.
So what's
than in rural areas?
You're in Lisbon. You have a southern European climate. Is that like a Mediterranean climate?
Yes, it's true.
Okay, so I guess we could compare that to maybe like San Diego in the United States. Does that sound about right?
I believe so. Basically, we have rainy winters most of the time. It's low temperatures, and the summer it's usually really hot.
Okay, all right. Let's move over to just indoor air quality in Portugal in general. I know you have a standard or a regulation, but what's the awareness like? I mean, does the common consumer in Portugal know that indoor air quality could affect their health, and do they have ways where they could call like an indoor air quality professional to come in and evaluate their home or their building?
Well, in my perspective, in fact, I believe that people, most of the people, the common people, don't are really aware of the importance of indoor air quality that it has on their lives, on their health, and how important it is. In fact, that is a problem that we have. And for example, if someone wants to do some evaluation of their indoor air quality, there are several laboratories that do that kind of work. But usually the common people don't know. And in fact, nowadays, in my research group, we are working in one research project nowadays that is called Life Index Air. That the main goal is to decrease the exposure to PM2.5, and we are in the first year of this project, and we are working with schools in Lisbon. And basically, we did an awareness campaign about indoor air quality, about air quality in general, outdoor, indoor, to the kids. It was kind of a 45-minute session with the kids explaining how important indoor air quality is, why it is important, and what can affect the air quality, which are the pollution sources, and also what can we do to improve air quality, the quality of the air that we breathe. And in fact, this is a really good strategy because in around 50 sessions that we did with primary schools, again, with kids from 6 to 9 years old, we did around 50 sessions, and we got to around 4,000 children. And that is a way of trying to introduce the theme of indoor air quality in the people's life, because it was really curious to see that the kids already know the basics of air, that it may harm our health, but they do not have the connections. So this type of awareness campaign was really good because they could connect all the dots, all the information that they had in order to understand the importance of air quality. And this type of campaigns are really good to let know the common people the importance of air quality. And it's a work in progress.
This is all kind of setting up the discussion of sleep and indoor air quality, but let me ask you this real quick. As far as PM 2.5 in Portugal, do you have a problem? Is it very high in Portugal compared to, like, I'm familiar with the national ambient air quality standards here in the United States. I know World Health Organization has ambient air quality standards, I believe, and do you typically, in Portugal, are you typically within acceptable ranges for PM2.5 in your outdoor air?
Yes. Usually we have acceptable values for PM2.5. Of course, there are specific sites located usually in urban areas where some monitoring stations that have some problems, continuous problems due to the geographical situation and huge traffic that it has over there, but it's only isolated spots. Overall, usually our PM2.5 levels are in acceptable range. Although one of the questions that I always think and always say is that most of the monitoring stations are only in urban areas, and for one city we have 5-6 monitoring stations. And my question is how that translates our real exposure to PM2.5.
Yeah, how representative is that of the true exposure, I guess?
Yeah.
What do you have any coal-fired power plants, or is most of your? I would imagine a lot of your PM2.5 is from traffic, from automobiles, trucks, buses, etc. Do you have any coal-fired power plants?
We have some, but for example, in Lisbon, the main source of PM2.5 is traffic, in fact. But we have some power plants nearby the big cities that sometimes influence as well. But the main source of PM2.5 in Lisbon, for example, is traffic, without any doubt, because usually people use a lot the car and not yet the public transport at this moment.
In the United States, probably the biggest indoor air quality issue, or at least the one that gets the most media attention, publicity, legal action, is moisture and mold. Is it the same in Portugal? Do you have, is that the number one concern of people in Portugal, or is it something else?
Well, when we are talking about indoor air quality, maybe it is the most immediate thing that people come to their minds when talking about indoor air quality, moisture and mold. It's the most visible maybe. But in fact, I think it's that those parameters are the most that people are aware, I think.
Most widely
they are
recognized.
Not aware of others.
So they're aware of mold and moisture, but not as aware of things like, ventilation, PM2.5, formaldehyde, VOCs, etc.
No, I believe the common person don't have that perception.
And now, what led to your? Go ahead.
Yeah, sorry. Tell me.
What led to your interest in indoor air quality and sleep?
Well, in fact, I went to a conference, to the Indoor Air Conference in 2014 in Hong Kong, and it was my first time on that conference, and for me it was an amazing one because there are several hundreds of persons over there, people that I usually read the papers, and I remember that at the end of the conference there was a session about indoor air quality and the future. What should we think about it? And at some point, someone told, people just are interested in indoor air quality in daytime, at work, at school, sometimes at home, but they always forget indoor air quality during sleep. And that was the moment when I started to think about this issue, and the main reason, and in fact it makes all the sense, is that we spend around 1/3 of our life sleeping. Usually, the ventilation is not so good, so it has all the conditions to have not very good levels of indoor air quality, and taking in account, okay, the levels may be lower, but we are exposed during 1/3 of our life, so probably it will have an interference in our welfare, in our life. So that's what was the beginning and the ideas that came to my mind when I started to think about this issue.
And when you started to look at that issue, did you find that studies on that topic were hard to find?
Yes, yeah. That was one of the problems. And in fact, until now, there are very few research papers about indoor air quality during sleep. And one of the things, it is published usually when they are talking about indoor air quality, it's only focused on only one parameter or two, maybe temperature, relative humidity, and maybe CO2. Studies focusing on complete set of parameters of indoor air quality, such as CO2, VOCs, PM2.5, PM10, it is really scarce in the literature nowadays. So that was one of other things that made me to start working in this area, to try to supply some information in this specific microenvironment and this type of setting.
You know, when I was reading your paper, I saw you had a list of the types of indoor air quality issues that people may be affected by, during sleep. And I found it interesting. You see all the usual concerns, CO2, PM2.5, carbon dioxide, temperature, relative humidity. But you mentioned a few others in the paper that I thought were kind of interesting. Things like flame retardants being added to pillows. Can you tell listeners about some of the other indoor air quality issues that maybe we don't think about all the time that are related to our sleep?
Yeah, the question is that we spend around 1/3 of the day sleeping, and the question is that we are with our breathing area really close to the pillow, to the bed clothes, and therefore it may have a really direct exposition to us by breathing, for example. So all the components that are usually used in those type of materials may be one of the pollutants that we will be more exposed in that specific setting of the bedroom, sleeping during night. And in fact, there have been some studies focusing on those type of specific materials in the bedrooms and in those specific sources, such as mattresses, the pillows, and so on, focusing on those new pollutants that are used, like the flame retardant materials, for example.
Yeah, I noticed you had in here that, I'll read it. Let's see. In bedrooms, typical specific sources such as mattresses emit phthalates, isocyanates, formaldehyde, and can contribute to total material emissions. You also said, additionally, mattresses, pillows, and bed linens are often heavily treated with flame retardants and contain residual detergent components and other substances known to have impact on human health. And then, of course, there's the potential for, dust mite feces and things of that nature. So it's quite an area that we get a lot of exposure, and I don't think it, like you say, it hasn't been well studied. One of the studies that you referenced in here was on CO2. It was the effects of bedroom air quality on sleep and next day performance, and it's a fairly new one, 2016. I think it was in Indoor Air, where they talked about lower levels of CO2 and how that improved sleep quality and the freshness of the bedroom. Can you tell listeners a little bit about that study?
Yes. This study, it is really recent. It is from 2016, and it is one of the first studies where they try to understand if there is a relationship between indoor air quality and the sleep quality. That, in fact, is one of the main goals that I work for, I can say. But in this specific study, what they did, again, they only focused in just one parameter of indoor air quality, the CO2 level, and they had a set of two different groups of volunteers. One of them, they had ventilation levels that were better than the other, and basically what they understood, it was that in the sets of people that had better ventilation, they had better next day mental performance, and also the sleep quality and the perceivedness of that sleep quality was improved when the ventilation was higher, which means that the CO2 level was lower. So overall, it was that conclusion that they arrived. So lower CO2 levels will have an impact on the sleep quality and performance of the people on the next day. It's the main issue.
And if any of the listeners want the reference on that, I'll send it to Cliff, and then he can put it in the blog. Cliff does a blog after each show, and he can put the reference for that particular study in the blog. But I thought that was an interesting and very current study, because there aren't a whole lot of studies on this issue. So what I'd like to do is, first, if you could tell listeners, just give them a quick overview of your study, what you were looking at, what types of contaminants you were measuring, and then we're going to break for our halftime in about 2-3 minutes. And then when we come back from our halftime, we'll go into more detail about your study.
Okay. So basically my study, it was a preliminary study. Our goal was to try to understand how could we study indoor air quality in bedrooms, because we have some of the monitoring that we use, they are not noiseless. But overall, what we did in our study was to do a multi-pollutant assessment in the air during sleep, where we studied temperature, relative humidity, VOCs, CO2, CO, and particulate matter, PM10, PM2.5, and PM1. And we studied 4 different ventilation settings. So this was done in just one apartment with one volunteer, and we studied 4 different ventilation settings. It was a natural ventilation, so basically it was one setting, door open, window open, door closed, window closed. So we tried to simulate the different ventilation settings, and at the end we could understood which were the exposure levels in each ventilation setting, basically that.
And you had 4 settings: door open, window closed,
yeah.
Door closed, window open, door closed, window closed, door open, window open. So, you got a good look at all 4 different scenarios. Do you have any idea what most people commonly do, with respect to that, one of those 4 scenarios? I mean, do they more often than not have the door closed and the window open, or do you know?
The question here is that usually we don't have air conditioning, so it's natural ventilation. So what happens is that, for example, in winter time, most of the people use the ventilation setting, closed door, closed window, everything closed. It means the ventilation rates will be really low, while in summertime or when the weather is warmer, people already open the window and also sometimes the door. So it depends a lot of the weather, the atmospheric conditions.
And in this particular apartment, what type of heating was there?
Excuse me? Can you repeat, please?
Excuse me. Yes, in the apartment that you studied, what type of heating was there?
This study was conducted in the summertime, so there was no heating at the time.
Okay.
But it was electric during winter time.
I see. It sounds like many of your apartments have electric heating.
Yes.
Pretty common. All right, we're going to break and thank our sponsors. We'll be back in about a minute and a half. We're going to talk some more with Dr. Canha. We're talking about the IAQ during sleep under different ventilation pattern study.
IAQ Radio would like to thank our association sponsors. The Indoor Air Quality Association, a nonprofit multidisciplinary organization dedicated to promoting the exchange of indoor environmental information through education and research. Visit them at iaqa.org. Particles Plus, engineers and manufacturers, feature rich particle counters, air quality monitoring, instrumentation, and vacuum pump technology. ParticlesPlus.com. Count on us. Grey Wolf Sensing Solutions, who use advanced sensor software technology and embedded computers to provide superior environmental test instrumentation. Visit them, wolfsense.com. IAQ marquee sponsors are John Donn Products, where restoration and abatement contractors shop. Visit them at johndonn.com. That's JONDON.com. Healthy Indoor Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions are available at IAQ.net. Legends Environmental Insurance, the experts in insurance for environmental consultants and contractors for over 20 years at legends-enviro.com. That's legends-enviro.com.
Okay, we're back for the second half of our interview. We've got Dr. Nuno Canha from the University of Lisbon in Portugal on the line. We're talking about sleep and indoor air quality. And Dr. Canha, you looked at air changes per hour, so that was kind of your ventilation rate. The CO2, carbon monoxide, VOCs, volatile organic compounds, formaldehyde, PM10, PM2.5, and PM1. Did I miss any?
No, I think it was all.
Okay, and then you looked at each of those IAQ parameters under one of the four scenarios, either doors closed, windows closed, door open, window closed, door closed, window open, door open, window open. First of all, how did you come up with those parameters?
Well, first I can say that for each ventilation setting, we studied during 3 nights, during all the sleeping period. And the selection of these parameters, in fact, it was based on our Portuguese legislation regarding indoor air quality. We can say, and in fact they are the most common parameters that are studied, with special focus on PM10, PM2.5, basically particulate matter. That is one of the things that we work a lot in our research group, and we also wanted to have an overview in the specific setting of the bedroom.
And as I understand it, we talked before the show, and that original Portuguese ordinance, and correct me if I'm wrong, I think it was from 2003 maybe, or 2006, was... Okay, it was tied to energy rating and public buildings initially. And then in 2013, if I understood correctly, there was another ordinance passed that was specific more to residential indoor air quality?
No, not really. What happened, in fact, Portugal had one of the best, and it was one of the first countries to have legislation applied in the law regarding indoor air quality. In 2006, indoor air quality was within the energy certification of buildings, of big buildings, public buildings, and all the others that have. It was bigger than some specific dimensions, we can say. And what happened is that for the certification of the building, all the indoor air quality was had to be okay. All the guidelines would be needed to be fulfilled. We can say that.
Okay.
And what happened? And in fact, it was not so easy as that. To have a big building to fulfill all the indoor air quality parameters. And it was not so easy to all the buildings to have that energy certification, taking into account that indoor air quality was not all fulfilled. And what happened, it was that in 2013, there was a change in the law that make a specific regulation just for indoor air quality. Basically, it took the indoor air quality from the energy certification, and now we have then specific regulation for indoor air quality, but it's not mandatory at the moment. Basically, this regulation for indoor air quality is only used when there is a complaint or there are some suspicions regarding some indoor air quality problem. Only then that legislation should be applied. And in fact, in my opinion, it was kind of a drawback from the beginning, if I can say so.
In what way? You mean in that it wasn't a requirement, that it was kind of voluntary?
Yeah, because before it was mandatory. So all the buildings, public buildings, restaurants, shopping centers had to fulfill the indoor air quality requirements. And nowadays, it's not mandatory. It's only volunteer. And this, I think it's a little bit of the image of our population, that they don't are so aware of the importance of air quality for our health. And so in my point of view, I believe it was kind of a drawback from the beginning.
When it was part of the energy code or the rating, how did, what happened if they were outside of the parameters? Did they have to make some changes to get within the parameters? Who measured to see if they were within the parameters?
Yeah, if they were not in the parameters, they would have to do some modifications and then do a second audit to confirm if everything was okay. And in fact, after 2006, several energy and indoor air quality experts were trained for this. That's a huge amount of people, experts, in those areas working in those specific audits, which are not necessary anymore, mandatory.
Interesting. All right, let's go back to your study, and let's look at the different parameters and how they varied or changed depending on the type of configuration, whether it was doors closed, windows closed, doors open, windows open. Because I find it interesting that some of the things you think maybe would have occurred did occur, but others didn't. That, for instance, when the doors were closed and the windows, let's start with doors closed and windows closed. What did you find then? So,
as it was expected, it was the ventilation setting with higher carbon dioxide, CO2 levels, due to the low ventilation rate, the air exchange rate that it had, of course. And it was possible also to see that that specific ventilation setting also promoted the higher VOC levels and formaldehyde. It was not so bad, but carbon monoxide as well. It was one of the issues that were above the guidelines, I can say, and formaldehyde as well.
Okay.
Along with PM2.5.
What happened with the PM2.5 with doors closed and windows closed?
Let me see. Can you repeat the question?
Yes, with the doors closed and the windows closed, what happened with the particle levels?
Well, with the particle levels,
yes. Did they go up?
What happened, we had, sorry, just to confirm here the values. Okay. So the PM2.5, PM10, for example, the levels were higher in other ventilation setting with everything open, but next to it, it was everything closed. The question here is, of course, the indoor air quality is not equal every day. There are different, or it depends on the atmospheric conditions, for example, or the type of activity we have in the room, and specifically in the beds, in the bedroom. If we move too much, if we use sheets and spread them away, it will influence on the particulate matter, in fact. So, but in our study, everything closed showed values of PM2.5, for example, above the guideline value that we have here in Portugal, that is 25 micrometers per square meter. And it happened the same, for example, for everything open.
And where were the measurements taken? Where in the room?
Measurements?
Yeah, where were they taken in the room? Was it in the middle of the room? Was it right above the bed?
It was around 1 meter away of distance from the bed, in the middle of the room.
Okay.
You can say that, for example, that it is not the real exposure that the occupant is exposed to.
Okay.
Because ideally, we should have the monitors right next to the heads of the occupants, for example. But taking in account that this specific microenvironment is really sensible for the noise, for example, because the noise of the equipment can interfere in the sleep of the person, we decided to put it 1 meter away, just to be not so bad.
Okay. And we'll talk in a little bit about what types of instruments you used, but let's finish with the 4 types of ventilation and what you saw with respect to the changes in these different indoor air quality parameters. So let's go to the doors open and the windows closed. What did you see then? Just general.
Generally. Well, over there, the values were below the guideline, almost to all the parameters, maybe except for formaldehyde, but usually they were below the guideline. The question here, when we think of the type of ventilation that we have in the bedroom, we should be aware of the type of emission sources that we have. It can be indoors, inside the house, for example, in the kitchen, or if the kitchen is connected really nearby to the bedroom or not, or outdoors, if we have outdoor sources. We should be aware of those sources in order to try to understand the levels of infiltration to the bedroom that will explain the exposure. And in fact, it was what was noticed here in this study. In other ventilation settings, for example, with everything open, we noticed levels of formaldehyde a little bit higher that were strange, but afterwards we understood that below the window of the bedroom there was a restaurant in the ground floor where people smoked, and that increased the formaldehyde levels inside the bedroom, for example. Mm-hmm. So it depends a little bit of the type of sources that we have in our house and also in the outdoor.
And what about a little more with respect to the doors open and the windows open? What other things did you see in your results that maybe surprised you a little bit?
Well, one of the questions, it was in fact that one, for example, the importance of outdoor sources when everything is open, for example, the formaldehyde from outdoors. But it was also the levels of PM2.5 that we found a little bit higher, the particulate matter also that are coming from the outdoor, for example. But with everything open, it means that we have good ventilation, high ventilation rate, and low levels of carbon dioxide, CO2, for example. That will improve our next day performance, as the other study that we talked about a little bit earlier showed. In my specific case, we could have found that some specific parameters were a little bit above for that ventilation setting with everything open, such as the formaldehyde and PM2.5. It was the two parameters that the mean values were above the guidelines that are established here in Portugal for indoor air quality.
And what happened with the CO2 when you had the doors open and the windows open?
In that case, the values were a lot lower, of course, because there was immediate the outdoor took away the CO2 basically, and the ventilation setting promoted air change rates in the order of 5 changes per hour, for example, while when everything is closed, it is around 0.7 changes per hour, air changes per hour. So if everything is open, of course the ventilation will be higher, and if we have emission sources in the indoor of the bedroom, such as ourselves when we are breathing with CO2, of course those levels will decrease because everything is open and it will be diluted. But the main issue here is that we should be aware that it can also happen outdoor infiltration to the indoor of the bedroom, and that can increase our exposure level to some specific pollutants.
I'm curious, what is the recommended limit for CO2 under the Portuguese ordinance?
In the Portuguese ordinance, we have the units micrograms per cubic meter, but focusing on CO2, during the conversion, it's around 1,161 ppm. Okay. It's the maximum value, the guideline value.
And
around 1,160 ppm.
So let's focus on that for a moment. Can you tell us what the CO2 levels were under each of the 4 different scenarios, like a range?
Yeah. So basically, the higher CO2 levels were found in the ventilation setting with everything closed, with the closed door and closed window, and that was expected. And that was also could seen when we calculated the air change rates that we calculated from the CO2 levels that were monitored. And we could find that the ventilation setting with the closed door and opened window had values below everything closed, and the other two were below as well when the window was opened and the door was closed. The question here, or the main message, I think, is that, okay, if we have everything closed, of course the ventilation rates will be really lower and the air change rate will be lower. That will promote the pollutants accumulation. In the other case, if we have any part or window or door open, that will improve the ventilation rate, the air change rate, and the levels of CO2 will decrease as well.
Were there any of the other parameters you measured that were outside of the recommendation from the Portuguese indoor air quality values?
Well, we could find there are, I think, let me confirm, there are three different parameters that were above the guidelines. The first one was regarding VOCs, that we found values above the guideline when everything was closed and also when the door was closed and the windows were open.
Okay.
The VOCs usually have indoor source from the paints or the floor, the woods that we use in our houses. And the other parameter was also formaldehyde, that we found a little bit higher as well. And PM2.5, particulate matter of PM2.5. And in fact, what we found was that particulate matter, most of it's fine particles, PM2.5. If we think in PM10, most of the PM10, it's the fine particles that we could see also in our study.
And you also measure PM1. Is that one of the standards in the Portuguese IAQ guidelines?
No. At this moment, we only have for PM10 and PM2.5.
Okay.
But taking in account that, for example, particles are smaller, so probably it will have an impact in our health because we can breathe them easily. And because our equipment allowed to do that test, we decided to include it as well.
And these bedrooms, if I recall correctly, they do not have carpeting. They had wood floors.
Yes, this specific one, it has wood floor, and it did not have carpet and so on. Yeah.
Okay. And what type of construction is it? Is it concrete, brick? I think I remember now. It was a double brick wall.
Nowadays, it's double brick wall. Yeah.
Okay.
Usually, the new constructions are like that.
Okay. So masonry is pretty popular over there. Is there anything else that, in the results that maybe surprised you a little bit?
I think the biggest surprise is the variability of the indoor air quality. Even sometimes in the same setting, it depends on several factors. Our exposure, it depends of what we do inside the house, what is happening outside, what we do in the bedroom, of what type of materials we use. So it was that big difference from one situation to other that for me it was the most surprising thing of our study.
And if you could just real quick tell listeners what type of instrumentation you used to take these samples. If I'm not mistaken, I thought I saw gray wolf in there somewhere.
Yes. For this, because we wanted to study how the evolution of the several parameters through all the sleeping period. So we only used real-time monitors for all the parameters. So we use a gray wolf device to temperature, relative humidity, CO2, CO, VOCs, and we also use more to a formaldehyde for formaldehyde levels, and the dust track monitor in order to assess particulate matter, PM10, PM2.5, and PM1.
Okay.
So it was those three equipments that we used.
And that's, I think Dust Track's a TSI product.
Yes.
And Grey Wolf, by the way, you probably didn't know this, but they're a sponsor of our show, so we're happy to see you use their product.
That's
all right,
it's a really nice equipment.
Good. Let's kind of wrap things up a little bit here. What future studies are you looking at? Did this kind of get you to think about maybe doing some other studies on indoor air quality and sleep?
Yes. In fact, this was a very preliminary first approach to this issue, indoor air quality during sleep. In fact, nowadays, I managed to, because I think the main question that we have to answer is if indoor air quality may affect our sleep quality, and if it affects how it works, that relationship. Because in fact, sleep is really important for us, for our next day performance, welfare. So that is the main question that I want to answer. So for that, what I did in the last couple of months, maybe already 1 year, I managed to gather a team of different experts from different areas in order to try to do a more deep study about this issue. So I have a team with sleep doctors, cardio-respiratory experts, and what we are doing at this moment, it's a study with 10 couples of the Lisbon area, and in each couple we studied their indoor air quality better. For each couple we studied during 10 days using actigraphy, basically to measure the level of activity, and we measured the indoor air quality in their bedroom during sleep. In this study, we are also measuring the bacteria and fungi levels as well before the night sleep and after they are awake. And at the same time, during that period of 10 days, we are measuring the sleep quality using a polysomnography technique. Basically, we are trying to understand the several levels of sleep that people undergo during the night. And the output of this study, what we aim, is try to understand if there is some specific air pollutants that may affect the sleep quality. So that is our goal at the moment.
Well, hopefully when you're done, we can have you back and talk a little bit about that particular project.
Yes.
Before we go, we always like to ask, before we go, if there's anything you'd like to add, any other comments you'd like to have listeners hear before we wrap it up.
Well, my main idea, in fact, is this type of show is really important to talk about the air that we breathe. because people sometimes are not aware of their importance, and this specific type of microenvironments should be studied a little bit more, because we need more data to try to understand our overall exposure in this specific type of microenvironment, the sleeping environment. And it was a pleasure for me to talk about our study in your show. And if anyone has any question at all, can contact me, and it will be a pleasure to talk about a little bit more.
We will, if it's okay with you, we'll put your contact information in the blog that Cliff is writing as we speak.
Yes, no problem at all.
Fantastic. All right, Dr. Nuno Canha, PhD at the University of Lisbon. Great show on indoor air quality and ventilation during sleep. Thank you for joining us. I want to thank my co-host, the Z-Man, Cliff Zlotnick. He's writing away back in the McKees Rocks studio. John, you got to have faith at the controls. This is Radio Joe Hughes saying thanks, of course, to our loyal group of listeners out there. We'll be back next Friday with the next broadcast of IAQ Radio.
For IAQ Radio, I'm Spike Reel saying thanks for listening.